The Department of Supply Chain Management at the Rutgers Business School, Newark and New Brunswick, is engaged in a large project that will produce a suite of detailed simulation models of ports of entry. The project is funded by the U.S. Department of Homeland Security and managed by the Borders, Trade, and Immigration Institute, led by the University of Houston. The end users will be analysts at Customs and Border Protection. Professor Benjamin Melamed, the principal investigator on the project, Professor Weiwei Chen, co-principal investigator, and graduate student Ming-Fei Teng make up the project team at Rutgers. Vast and sustained flows of people and freight through ports of entry are essential to the U.S. economy. Excessive delays at border crossings translate into a variety of burdens and costs, including inconvenience to travelers because of delays and missed connections, increased supply chain lead times, and their ensuing disruptions, as well as an elevated transportation carbon footprint, which has environmental and public health consequences. Freight handling at U.S. border crossing points constitutes a case in point. Overland transportation of goods across ports of entry is a key component of supply chains, which supports trade into and out of the U.S. Consequently, it is in the national interest to ensure that freight hauling trucks cross a port of entry as quickly as possible, but without compromising immigration and cargo security inspections by Customs and Border Protection personnel, or truck safety inspections by the state housing the port of entry. To this end, U.S. government agencies are interested in monitoring congestion in terms of delay and crossing times. When congestion becomes abnormally high, it is necessary to take corrective actions to restore wait times to normal levels. Such corrective actions may be strategic, such as creating additional lanes at the port of entry or stacking an additional inspection booth in a lane. The corrective actions may also be tactical, such as opening new lanes and diverting traffic from congested ports of entry to less congested crossings. However, adding resources incurs costs. The challenge is to find the proper cost-benefit balance.
The broad objective of the project is to provide a suite of simulation modeling tools that can serve to answer what-if questions. This suite of models has been dubbed Port of Entry Simulation System, or POS for short. The screen shows the Bridge of the Americas, also known as BOTA, in El Paso, Texas, which will serve as a working example.
The project creates a model using the AnyLogic simulation platform, which uses visual facilities for creating model objectives and Java programming for specifying object behavior.
Each port of entry model uses traffic animation at user-provided time granularities for detailed observation of how model scenarios unfold over time.
Animation tracks the motion of each vehicle from the time it arrives at the port of entry until its departure.
A port of entry model includes its layout on a geographical map. Here we see a top view of the Bridge of the Americas. Zooming in for a closer view, we see that the Bridge of the Americas actually consists of two ports of entry, one for privately owned vehicles, referred to as POV, on the left, and one for commercially owned vehicles, referred to as COV, on the right.
The port of entry layout is captured by the simulation model specific to each crossing. For example, we see the passenger-owned vehicle layout with traffic moving northward. This crossing has multiple stages, including pre-primary inspection, primary inspection, and secondary inspection. A more detailed three-dimensional view of the passenger-owned vehicle lanes is shown in this figure.
The behavior of trucks in the commercially owned vehicle lanes is more complex. It is governed by this flowchart. It captures additional stages of inspection for radiation, X-ray inspections, and the unloading of suspicious trucks for more detailed inspection. A more detailed three-dimensional view of commercially owned vehicle lanes can be seen in this figure. A simulation model produces as output statistical estimates of performance metrics. Performance-related output that is of interest may include time series of waiting times and resource utilization, as well as their statistics. Such statistics include histograms, means, variances, etc.
The port of entry model is configured by entering input parameters into an Excel file. Similarly, the simulation model saves its output in an Excel file for further analysis.
An important feature of POS is the capability of simulating traffic disruptions. This feature allows analysts to create, turn on and turn off physical obstructions in a port of entry model which capture traffic disruption due to various adverse events such as car accidents or disablements, road construction, etc. The analyst can then gauge the resultant congestion and the dynamics of deteriorating performance measures, mainly waiting times. This ability would be useful for port directors as well as preparedness and response organizations.
A simulation system serves as an in vitro lab by allowing the analyst to conduct experiments with various port of entry configurations and parameters, primarily for planning purposes. A typical planning purpose might be to assess the benefit of opening additional lanes, adding personnel, or speeding up inspections based on pre-vetting of drivers. Other applications might be preparedness planning to assess the impact of a surge in traffic due to a natural disaster, an industrial accident, or another type of emergency or traffic disruption. The Bridge of the Americas model is the first of several that the Rutgers team will create for Customs and Border Protection as part of its project. For questions and additional information, please contact the principal investigator.